This is part 3 notes for chapter 11. We are going to be looking at organizing data graphically. So we're going to start with a dot plot, which is a graph that shows each data value plotted as stacked points above a number line. So for this example, the following data shows the heights of 25 randomly selected 11th grade females in centimeters. So I did most of these already, but really you're just putting a dot above that number. So I left the last 3 here for us to do together. So we have 152, 168, and 152. So since we have 152 first, I'm going to go ahead and find 152 on the number line, and then I'm going to put a dot. After I put my dots, I like to put a line through so I don't accidentally do it again. Then we have 168, so I'm going to go ahead and find 168. So I already had put 2 dots there from a little while ago, but it's okay. I'm just going to put the third one above it, cross it off, and then the last one is 152 here, so I'm going to go ahead and put another dot and then cross it off. So you can go ahead and pause the video so you can put all your dots above the number line as well, and then we'll move on to the next part. The next part says to draw a histogram to display the data. A histogram is a bar graph that shows how frequently data occur within certain ranges or intervals. So we're going to be looking up at our dot plot to be able to look at the frequency so we can make our histogram. So when I'm looking here and it says 141 through 150, so what I do is I look up at my number line and I'm looking for how many dots do I see between 141 and 150. So when I look, all I see are the 2 dots above 150. So that means my frequency is 2. And we can put 2 tallies. It depends. I mean, if you're doing ones that have really big numbers, you don't really have to put the tallies. Then next, we're going to go ahead and look between 151 and 160. And I see 10. And then we can put the tallies if we want to. So we'll go... All right, and then so on. So when we look 161 through 170, I see 9. From 171 to 180, I see 3. And between 181 and 190, I see 1. So now we can make our histogram. So on our the x-axis, we can see the height, and the y-axis, we can see the frequency. So because the frequency is 2, for the first interval, I'm going to go ahead and just make a box like this. Then from 151 to 160, it's 10, so I'm going to make another box. And then 9. Then 3. And then 1. All right, and that's all for the histogram. So let's move on to the next part. So now we're going to be drawing a box and whisker plot to display the data. And a box and whisker plot is a graph that shows the distribution of a set of data along a number line, dividing the data into 4 parts using the median and the quartiles. So this one's probably the most complicated, but it's what we're going to be focusing on when we do our project. So here, it says write the data in order from least to greatest. So I did that first already. So you could pause the video and go ahead and give that a try. It is a little tricky without the dot plot. So if you look up at the dot plot, it's a little bit easier to get your numbers written down versus looking at all of them up above since they're not in order. Then it says to label the minimum, maximum, median, lower quartile, and upper quartile. So when we click stat and we go to edit our list, I already entered all of these in, but you're going to want to take time to do that and make sure you look at the board if you need help with the directions. From there, we're going to go ahead and calculate. So we're going to click stat, go over to the right, the very first one, and then depending on what calculator you have to enter a little differently. So the only ones that they're asking us for are the minimum, maximum, median, lower quartile, and upper quartile. So we already know what the minimum is. That's 150. We can see the maximum, that's 188. And looking here at our calculator, I can see that the median is 163. My Q1 is 156, which we don't have that here. So we're going to go ahead and use 155. And then Q3 is 168. Okay, so the next part, we want to draw our box and whisker plot. But first thing that we need to do is go ahead and look and see if we have any outliers. The reasoning for outliers is that because that could change our max and min a little bit. So looking down, let's just use the space down below here. So we have to look for outliers. So the formula for that is Q3 plus 1.5 times the IQR, and then Q1 minus 1.5 times the IQR. So once we do that, well, we already know that our Q3 is 168, and we're going to add that to 1.5 times, and remember the IQR is Q3 minus Q1. So Q3 is 168 and Q1 is 155. So that means our IQR is going to be 13. And when we type that into our calculator, we get 186. And then we take 155 plus 1.5 times 13, and that gives us 138. So remember when we talked about outliers, we said, okay, well, if any of our numbers up above are below 138 or above 186, they are now an outlier. So what this tells me here is that this number 188 is actually now an outlier. So it's no longer our maximum point. We're still going to put a dot in a little bit, but it's no longer the biggest. 175 is smaller than 186, so now 175 becomes our new max. All right, so now to draw our box and whisker plots. So what we're going to do is we're going to put different dashes on each, like put a dash for each point. So for the minimum, since that is 150, I'm going to put a dash here. Then Q1 is 155, so I'm going to put that here. The median is 163. Q3 is 168. And then the maximum is 175. So we have our min, Q1, median, and our Q3, and then the max. So with the Q1, median, and Q3, we put a box. So our box and whiskers, right? So here's our box. And then with the minimum and max, you're just going to make the whiskers. But we can't forget about our outlier. That was 188, so we are going to put a point there and then just put outlier. And that's it. So the last question here just says, compare your box and whisker plot to your dot plot and your histogram. Do the three plots tell the same story and explain how? So if you look at all three of them, they definitely look similar in a way. You can see where most of the points are and then where they get spread out a little bit. So the way that we can word that is say, yes, all graphs, show roughly symmetrical data. Okay, and for your assignment, you're going to go ahead and go to the next page. This is something just interesting to look through, and it might help you with a problem here coming up in your homework, but just looking at what it means to be symmetrical, or when it's skewed right or skewed left.